Okay, today we are going to start the paper solution, which is related to Pearson Edexcel International GCSE 921, Friday, June 2023. Okay, uh, let's start this paper. This is basically 70 marks paper, and all the questions should be attempted, and every question and every page should be read. Some formulas are given over here for the reference. If some students wants to use them, he can use it. Here he is saying for the question number one, he is saying over here that the boxes show some physical quantities and their units. Draw the straight line from each physical quantity to its correct unit over there. For the velocity, the unit is meter per second. So I will join this line to my meter per second over here. And for power is the unit is watt over there. And for moment is Newton meter. Newton meter. Wait a second, I will have to scroll down a little bit. Newton meter for the moment over there. So moment is Newton meter because it is the product of force and this perpendicular distance or displacement over there. And acceleration is having meter per second squared over there. So these are the units which I have to match the column from question I will have to do. Some physical quantities are scalar and other physical quantities are vectors. State the difference between scalar and vector quantities over there. So I will say here that the quantities with the quantities which have have magnitude and unit, magnitude and direction are called vectors, and on the other end which can be are called vectors over there, and scalars are having only magnitude only, then we can say they are called scalar quantities. On the other hand, give the example of a scalar quantity. We can simply write about this. Any scalar quantity that can be work, that can be speed, distance, anything you can write over there. Speed can be distance. For 1 mark, you will need only to write down work over there. It can be work, it can be power, anything which is a scalar quantity over there. This was our question number one. For the question number two, he is saying over here, the question is about different methods of generation of electricity, and natural gas is used, can be burned to generate electricity. Name the energy stored that decreases when natural gas is burned over there. So when natural gas is burned, then it means the chemical energy stored in that natural gas product over there is going to decrease in the form of conversion into heat over there. In the next, he is saying burning natural gas and movement of water waves can both be used to generate electricity. Discuss the advantages and disadvantages of the method of generating electricity using the natural gas over there. So when we go for advantages, we can say electricity can complete our energy demand or electricity demand. Electricity electricity demand for any urgent purpose in case of load shedding, etc. Electricity demand can be fulfilled. On the other end, if we go for the second one, that it is reliable. It is not to be like when the natural gas resource or any natural gas production where natural resources of natural gas or petroleum or diesel are available, then they are more reliable. There is no load shedding. So we can say it is reliable over there. And for the second one, he was also asking about the disadvantages. The main disadvantage is that it is non-renewable. It is not to be produced. These were the advantages. And if I go for disadvantages, Then I can say here that according to disadvantages, it is non-renewable. It cannot be produced again and again. Non-renewable resource it is. We can also write about it that it is producing carbon dioxide gas on burning. Produces carbon dioxide gas on burning as pollutant. Burning as pollutant to the atmosphere. Pollutant to atmosphere over there. Okay. And for the next question, we should move on now. This is the blank page. Now he is saying over here, a cleaning product is uh, applied to a car using a sponge pad. Okay, the sponge pad is rubbed against the car to apply the cleaning product. Means it should be rubbed in this format where it is shown in the form of picture over there. Some parts of the car are made up of metal and other are made up of plastic. Okay. So he is saying the metal parts of the car are earthed. Explain why the pad becomes charged when rubbing plastic, but not when rubbing the metal parts over there. So when we are rubbing with plastic parts, we can say that plastic is an insulator, metal is a conductor, and in both cases we can say that I'm going to write a little bit about this. I will say here plastic is insulator later while metal is a conductor. And then we can say uh, electrons or charges will not be, even though in case of metals they will be produced, but they will not stay there. They will not deposit in the form of charge over that body, and the charge or electrons will be transferred by rubbing friction over there. When I'm rubbing my this pad on the plastic particles, when we rub the pad on plastic parts, electrons move electrons move from uh, from pad to plastic or plastic to pad over there to make them positive or negatively charged over there. So on plastic parts, electrons remain to build up a plastic parts over there. So charge will build up. Electrons will be remaining on the plastic pad over there. So electrons flow through the metal parts, travel to Earth, because he is saying over there, he has also mentioned that even though in the case of metal parts, that can be earthed. So if it is earthed, then electrons will move towards the earth to neutralize it. So when pad pad is passed over metal surface which is earthed, which is earthed, which is earthed, will allow the electrons to move towards earth. Electrons to move towards earth if yeah, it's fine. So electrons will move towards earth over there. Okay. Okay, he has given also some examples over there to explain this. He is saying the sponge pad is held near a metal post that is connected to the ground. The sponge pad discharges with small spark the air to the metal post. Then what is happening? The sponge pad stores 5 millijoules of energy in electrostatic store. Okay, and the voltage between the sponge pad and the metal post is 6000 volt. Calculate the charge transferred. So here we will use the formula of definition according to voltage that is given here. Voltage is equal to work done per unit charge. So I want to calculate the charge over there. Then I will say work over uh, work over charge, no, work over uh, voltage, voltage. So work was in the form of energy as 5 millijoules. 5 multiplied 10 raised to power minus 3 over 6000. And if I simplify it, I will get, then it will be like 5 by 6. 5 over 6, that is 8.3 multiply 10 raised to power minus 7, and the unit of charge is coulombs, so it will be written with the symbol C over there. Then he is saying the small spark between the sponge pad and the metal post demonstrates that the sponge pad is charged. Describe the different experiment that could demonstrate that the sponge pad is charged. You may draw the diagram if you want. So I will simply say here that if I take the sponge pad, if, for example, this is my sponge pad and I bring it to an uncharged body or near a charged body over there, and I say that this is uncharged body, and this sponge is charged or not charged, then there will be attraction and repulsion between it, which we can say if we take this sponge to near to an uncharged insulator body. I'm taking this is an insulator body, insulator body, and I'm taking this sponge near to it, which is positively charged, for example, which is positively charged. What will happen? And that it will arrange its negative charges on this side and positive charges will go because of the repulsion to the other side. So in explanation, I can write over there that when when we bring the sponge near an uncharged insulator body, then when we bring the sponge near the uncharged body, then if charge is present on sponge, then then it will induce opposite charge on the near end of insulator body. And on the other end, if I take some near the charged body, then it will be attraction or repulsion will also be shown over there. And this induction of negative charge will show attraction between sponge and sponge pad and insulator body over there. Okay, now he is saying that the photograph shows a dummy test of the safety features of a car in Cluyon. Okay. This is a dummy in the form of robot, that if some car has an accident, then how these airbags are going to open over there. Before the collision, the dummy in the car is traveling at a velocity of 14 meter per second. Okay. And the dummy has a momentum of 11 kg meter per second, 11,000 or 1100 kilogram meter per second. State the formula linking momentum, mass, and velocity. So we can say momentum is equal to mass multiply velocity over there. So we can also write it momentum as P is equal to M multiply V over there in the form of symbols. Show the mass of the dummy is approximately equal to 80 kg. So from the just putting the values into this formula, we can simply get that our momentum is 11,000. So P value is 1100. So is equal to mass I have to show in the form of answer multiply velocity is 14. So when I go with 1100 divided by 14, then I am getting the answer is equal to, for my mass, just go for calculation of this, then mass is almost equal to 79 kg, which is approximately equal to 80 kg, which is shown for it. Then he is saying in the B part over there that the dummy is brought to the rest during the collision by the 15 kilonewton force. Calculate the time taken. So here I am using the relation of impulse, that force is equal to change in momentum over time taken. So he is saying calculate the time taken. So T is equal to delta P over time is being calculated, and so 15 kilonewton as in the form of force should be provided over there. So the momentum value which I have calculated for the above one with the given form, that was 1100 kilogram meter per second. So that is 1100 over 15 kilonewton, 1100 over 15,000 Newton over there. Then we can say by calculation that our time is time is equal to 0.073 0.073 seconds over there. Okay, then he is saying that the car being tested is fitted with airbags. Using ideas about momentum, explain how airbag reduces the force of experience, that reduces the force of experience by the dummy in the collision. So dummy is just like a robo. He is saying that if what the airbags are being used, about how they can reduce the force which is going to hurt the dummy over there. So here he is saying that we can say airbags basically the collision time, which is reduces the rate of change of momentum, basically, which reduces the rate of change of momentum. If I can show you here, again, I am using the simply formula F is equal to delta P over delta T. And if I increase this time, definitely this force will decrease, which is experienced by dummy. And accident, if it happens, even though, then it will not too much damage to the dummy during the collision over there. In the next question, he is saying that the question is about specific heat capacity. State what is meant by specific heat capacity. The amount of energy required to increase the temperature of 1 kg mass of body through 1 degree centigrade or 1 Kelvin, we can say it is called specific heat capacity over there. In the next part, he is saying over here that it is the diagram shows a sample of solid stearic acid being heated in a boiling tube using a water bath, okay, to give the smooth heats flow to this thermometer in the form of water bath over there. He is saying over here the mass of stearic acid in boiling is 58 gram over there. So when the boiling tube is placed in the water bath, the temperature of the stearic acid is increases from 27 to 37, 21 to 37. Okay, 16 degrees centigrade increase over there. Stearic acid does not melt. And as the temperature of the stearic acid increases, the additional 3500 joule energy needs to be transferred electrically to the water bath. Using the data about the specific heat capacity of solid stearic acid is approximately 4 joule per gram over there. So I will have to show that specific heat capacity. Okay, so we have the formula Q is equal to MC delta T or delta theta over there. So I need the C over there. C is equal to Q over M delta theta over there. So Q is basically given in the form of 3500, and I don't need to convert this 58 into kg, kilogram into kilogram, because here he is saying to show me again in the form of gram, and so I can say only to use in the gram form. Over 58 multiplied by the difference of the temperature, that is 37 minus 21, that is 16 over there. If I simplify this whole value over there, I will get C is equal to 3.8, which is approximately equal to 4 joule per gram per degree centigrade over there, or per Kelvin over there. We can also use that value over there. The true value of the specific heat capacity of solid stearic acid is 2.3. Give the reason uh, for the difference between the value. Now he is saying that your value is coming, that is approximately 3.8. Give the reason, the difference between the actual value and the true value which is being experienced by the calculation over there. So we can say over here that some energy also heating boiling tube. So some energy is used in heating boiling tube, which was present uh, in the water bath over there. This reason can be to the change in specific heat capacity value over there. And there can be, we can say stearic acid is not pure. Stearic acid solution or stearic acid is having impurities. Having impurities. We can also write some other reason over there, that energy is being transferred or lost to the surrounding over there. Energy can be lost into its surroundings over there. So we should also move on over there. Okay, this is related to electricity and magnetism over there, I think so. The question is about electromagnetism. Okay, diagram 1 shows uh, diagram 1 shows the magnetic field around the straight section of the copper wire. Okay, magnetic field is shown. So copper wire is having definitely the current which is passing through it, and right hand grip rule will tell us. So if I hold this wire, then I will say that the direction of current will be drawn in this form, that it should be going in this direction over there, from left to right over there. After that, he is saying over there, explain why the copper wire has the magnetic field around the diagram. So according to right hand grip rule, grip rule, grip rule, right hand grip rule, that when current passes through uh, passes through a wire, then magnetic field is induced. Magnetic field is induced around the wire, which can be determined by right hand grip rule, which can be explained that if we hold the current carrying wire in our right hand and thumb thumb shows the current, then curly fingers will show direction of magnetic of magnetic field over there. So it is the explanation about this, that whenever a current carrying wire current is passing through a wire, then a magnetic field is induced by the phenomenon of electromagnetism. And I have also explained a little bit more over there. So the current must be from to be taken into the sense of how diagram is showing over there. Okay. We should move towards the part B over there. He is saying a student investigates how the strength of electromagnet varies the current in the electromagnet. The diagram shows their operators: ammeter, variable resistor, load, and electromagnet. Okay. The student's method to switch on the electromagnet is at its maximum current. Place load of 100 gram over there. Okay, so that is above the floor and electromagnet, and slowly reduces the current and electromagnet until the load falls on the electromagnet. Record the current at which loads falls. Record the current at which the same loads two for more times. Repeat the method of loads of different. Suggest a suitable safety precautions for the investigation over there. So I will say here in the form of safety precaution. Okay, safety precaution to do all of these experimentation repetition over there. I will say uh, avoiding fall of objects from hitting hands or feet. Say, first of all, the student or the person who is performing, save your feet, save your feet from hitting of falling hard metal bodies, falling hard metal bodies or masses over there. This can be the precautionary measure, and we can also take that protecting the floor from damage, like put little bit of sand on the surface of the soil over there, protecting the floor from damage over there. Okay, let's move to the next part over there. Okay, he's saying the table shows uh, he has taken the current at which the load falls in ampere is given over there 1, 2, 3, 4, 5. Okay, for the last one, he is saying calculate the mean over there. Also, calculate the mean when the current mass is 600 gram. You will add all of these values and just divide them by 3 over there. So you will say here that 1.79 plus 1.84 plus 1.87 over 3, and you will get the value of 1.833, 1.83333, so up to three significant figures. Now suitable, because after that 3333 is coming, so I'm just ignoring the remaining ones over there. So I can say here it is 1.83 amperes over there. After that, he is saying on the grid, um, okay, on the grid, plot a graph of mean current against the mass of the load. Against the mass of the load. Okay. So, mass of the load is taken from where to where? Wait a second, I can check. It is from 100. Okay, so I'm taking my small box equal to 100 over there. 1, 2, 3, 4, 5, 6. Yeah, it's fine. Okay, so I'm saying here I'm taking 0. According to the current is having maximum value because the masses are given already over there. So current is going to 1.83. So I am taking it 0.5. Or should I take 0.4? No, it's fine. I'm taking 0.5 over here. Wait a second. For the big box, I'm taking 0.5. 0.5, 1, 1.5, and 2. Why I have taken these values, I will show you here that according to table, the maximum current is, mean current is 1.83, and maximum load is already being on the x-axis drawn for me. So on the y-axis, I will have to arrange and to make the scale properly. So I will say here that I have made a scale that my one big box is equal to 0.5 ampere, and 1.83 ampere will be coming over here. 0 to 100. When it was 100 gram, then it is 0.30. For 100, it is 0.30. So for 100, it is 0.30. So it is 0.1 here, 0.2 here, 0.3 is here. So I am marking my first point when it is 100 exactly to parallel to this. So this is my value for the first one. Okay. I should also go to the second value. So let's check where is the second value over there. Second value is going towards 0.58 and then 0.89. 0.58 first. 0.58. 0.5. then 0.6, 0.58. So it should be in the middle, little bit above. So exactly taking 0.5 middle above, my value is lying on 200 is here. After that, he said to me to go for the next value. That was, I think so, 0.89, 0.89 and 1.23, 89 and 1.23, 0.89, 0.89. So 0.5, 0.678, 0.6, 0.7, 0.8, 0.89. So just from the middle of above, it is almost here. After that, 1.23. So it is 1, uh, 1.1, 1.2, 1.23. And in the last, I think so, that is the last value. No, it is, I also have the 500 value. 500, for 500, it is 1.5 and 1.83. 1.5 and 1.83, 1.5 and 1.83. So it is 1.5, 1.83. For 1.83, 1.6, 1.7, 1.8, and it is here. So if I join these all of these points, then I will say here that I am getting almost the straight line over there, which is not exactly drawn. Wait a second. My one point was here. So I'm saying here I'm taking all of these points to be taken and almost taking the line over there to be drawn properly. So I will say here that it is going in this form, like in this form. Okay. And if I have drawn this in the form of my best fit line over there, then he is saying the student predicts that the load of 1 kg will fall when the current in the electromagnet is 3 ampere. Comment on this, his prediction over there. So if I just increase the load over there, then I know that the current is increasing already in the mean value over there. So we can say here that when we go for it, that 1 kg like 1000. So he is saying here 1000, for 1000, that ratio supports the value of 3 ampere. So when the collected data graph will go out, so pattern may not continue outside range of the data of the graph. So we can say here uh, when we take the mass 1 kg, then we can say it is out of range, out of range of graph. So we cannot predict that it will be exactly 3 ampere. The question is about, here is saying the question is about the sound waves over there. If this is frequency can be heard by human or not. Uh, as we know, from 20 hertz to 20,000 hertz, we can hear from here. He is saying over there that for this question, he is saying, okay, this is not, first one is not going to be taken because he is saying place the ticks over there. 30 in the range, 500 in the range, 20,000 in the range, 2,000. 10,000 is in the range because the range is 20 hertz to 20,000 hertz. 25 is out of range over there. Now he is saying the diagram shows the screen of the oscilloscope. Sound wave is detected. Add to diagrams by the drawing the trace of another sound wave that has a lower pitch and quieter than the sound of the wave shown. So it should be definitely of the lower amplitude, and it should not uh, with the lower frequency throughout. So we can say it will be with the wave drawn with the lower amplitude and like lower frequency. So we can say here that, for example, I am taking this one and this one. No, I will have to make it straight more. Wait a second. This one I am taking to be taken in the form of this and this. Oh, I should scroll down a little bit more so that I can see the picture clearly. So from here I am erasing. So I am taking this wave to this form and this wave to this form. So this is the wave which I have taken for it, which is having a quieter sound with the lower frequency over there. Here he is saying that the speed of sound in the air varies with temperature. A student finds a formula in the textbook of this. Calculate the speed of sound when, if the air temperature is 46 degrees centigrade. So for this, first of all, I will have to convert my degree centigrade temperature into Kelvin. So temperature in Kelvin will be given as 46 degree centigrade plus 273. So I will get my value, that is 369, and then it will be 319. Okay, Kelvin. So I will put temperature in Kelvin plus 166. I will get my speed of sound in air over there. Then I can say speed will equal to 0.606 plus multiply by multiply by 319 plus 166. Then just by calculating using a calculator over there, I get it is 360 meter per second. Okay, then he is saying calculate the wavelength of the sound if the frequency is this at 46. So V is equal to F lambda. He is saying me to calculate the wavelength. So lambda is making subject V over F. So V was equal to 360 over 15,000, and I will get my answer over there in the form of 0.024. 0.024 meters is the wavelength of that sound over there. Here he is saying that some absolute magnitude and color and mass of solar masses. Mass in solar masses. Okay, there are four stars. Star C is much more powerful than star A. Okay, star A and C appear to have the same brightness over there. When viewed from Earth, suggest how this is possible. So we can say here that star A is closer to Earth over there. Then see, star A is closer to Earth than C, and what he's saying that is more powerful for that appearance over there. Then he is saying using the information from the table, explain which star is the supernova stage of its evolution over there. So according to its absolute magnitude over there, I will say that this is having minus absolute magnitude over there. It means this is in the supernova giant stage over there. Um Star D, and its mass is in solar masses, means sun mass. So that is much, much larger than sun over there. So I can say it is, I am writing a little bit about it over there so that it can be more clarified. Uh, Star D is in supernova stage because it is only star that has mass. It is only star that has mass much, much larger than sun, because that is 17 approximately. Mass much, much larger than sun over there. And we can say because it is much lower value of absolute magnitude also, and it is having negative absolute magnitude value, having negative magnitude value, which is very less, very less over there. So it is in supernova stage over there. Explain how man sequence star evolution into supernova over there. So from here we can say how we can go to supernova stage. How a main sequence star evolves into supernova. Okay, so I will say here that hydrogen fusion stops in the core of that main sequence star. Hydrogen fusion stops in core, and definitely if hydrogen fusion stops, then core will collapse, and core collapses. And if it collapses, so which and core collapses, which restarts hydrogen fusion over there. So we can say here that from this stage, when the restart of hydrogen fusion is restarted, then we can say stars. So stars become star will become super giant over there. And so when heavier elements, on the other hand, if we say when heavier elements are going to fusion over in the core, and the fusion of heavier elements is going to happens in core, then star explodes as supernova. Then star explodes as supernova over there. Okay, now he's saying over here that we are using in the form of astronomers are used to supernova distant galaxies to investigate the explosion of universe. Light emitted from the supernova in the wavelength this, a detected answer wavelength is this. So calculate the speed of the galaxy. Okay, we are only using a Doppler shift formula over there, which we can say we can take as delta lambda over lambda is equal to v over c. Here c is the speed of light and v is the speed of galaxy, change in wavelength and original wavelength over there. So if I go for calculating change in wavelength, so 7.78 minus 7.7, and here it is meters and 7, okay, 7.78 minus 7.774, multiply, both are having 10 is power minus 7 over there. So I will say delta lambda will equal to, wait a second, 7.78 minus 7.74. Oh, it is becoming 6 multiply 10 is to power minus 10 meters. So this is my change in wavelength over there. So from here, I will have to put my original wavelength over there also, as which was the supernova wavelength 7.74, 10 is to power minus 7 in place of this wavelength. 6 multiply 10 is to power minus 10 over 7.74 multiply 10 is to power minus 7, which is equal to v over c is also going to be multiplied 3 multiplied 10 is to power 8. And if I put all of these values into calculation, then I get that the speed of the supernova is 2.315 multiplied 10 is to power 5 meter per second over there. Here is saying the astronomers investigated that the supernova that showed a redshift in the wavelengths detected in different galaxies. The astronomers discovered that the red-shifted light detected from supernova is nearby galaxies had a shorter wavelength than the red-shifted light detected by supernova in the galaxies further away. Explain how the discovery supports the Big Bang theory. Okay. Like according to Big Bang theory, we know that whenever we look towards very nearby, when nearby galaxies show smaller change in wavelength, show smaller change in wavelength in the form of redshift, smaller change in wavelength in the form of red shift over there, then we can say they are, it means they are traveling at very slow speed. So they are traveling slow, they are traveling slow than further galaxies over there, then further galaxies. And so it is shown by, according to Big Bang theory, that all the light red shifted galaxies suggest that the universe is expanding. So this red shifted, for moving away, red shifted shows the expansion of universe, which is responsible for uh, we can say it was a small point in the start that was universe, and it is continuously expanding from the billions of years. So in the point that universe is started from a point over there. Okay, what is he saying in the next question over there? It is a blank page. Okay. It is a blank page. Okay. Okay. Equations booklet is attached. Okay, this was your whole paper over there, where he has much more. If I just look over these formulas and the paper which we have done over there, we have used the formula. If we see here, not directly anyone. We have just used energy transfer charge multiplied voltage. We have used this formula in our calculation. We have used this formula in our calculations over there. We have not used any other formula from here. Then we have used any other formula if we did use over there? No more formula we used. So from here, I will say that these formulas are supportive. If mostly the student asks that should we memorize these formulas because it's not neat over there. But on the spot, when the question is going on and you are going to find out where is the formula sheet and what was the formula and which is going to be implemented, this is not for easy for the student to identify which he should use for the solution over there. So it's better for the student to memorize these equations easily and the formulas and the basic definitions so that your exam can go good. Thank you so much for this paper. See you in the next paper.